So today I'm going to be demoing SQLite. If you remember in my really cool video, I talked about SQL, and SQLite is just a specific, I guess, version of SQL. So without further ado, let's get started. So let's try to create a table, but first I guess I have to start SQLite. Okay, so does everyone see this on their screens? If you type just SQLite 3.
Would we do this in terminal?
Yep.
Yeah. Oh yeah.
You
Open
can
up
do
your
this
terminal.
anywhere.
Yeah.
Anywhere in terminal. It can be any directory. Thumbs up? Yes? Cool. Okay. Okay, now let's try to create a table. So I'm going to type the SQL keywords in all caps, and let's just say I'm going to create a user table. User is lowercase because that's the name of my table. And then I'm going to say a column is an ID. Its type is going to be integer. It's going to be a primary key. If you remember in the video, primary key is something that you can refer to as something that's unique in each of the rows of this table user. And I'll want it to auto increment because you want IDs to be unique. Is everyone good on this? Cool. Now I want to have another column just for the name. The type will be text. So this is just string. And then I'll say it's not null. And this just means if we're gonna have a field called name in here, and if you want to add data into this table, you have to have name filled out. And then we can also add an age, so this will just be type integer, and not null is the same thing as name, and then we'll just say, okay, let's add an email. And this will be a string, but in SQLite, it's called char. And then we'll have an ending parentheses and a semicolon. So before I click enter on this, do note that you don't have a comma after your last column. So, do you see my mouse? Yeah, so no comma over here. If you put a comma, it will not work. And you'll be like, what is wrong with this? Like, it looks fine to me. And you have to have an ending parentheses and you have to have a semicolon. So this isn't like Python where you can just omit the semicolon. Yes?
We make a mistake on the line before. Can you go back?
Yeah. Wait, what do you mean if you make a mistake?
Let's say you forgot to put a comma over. How would you go back to that line?
I guess you restart. Unfortunate, very tragic. But just do know that the reason why I'm doing this demo is not because you'll be writing SQL queries, but because it'll help you understand when we're doing this in the code, like what this actually means. Cool?
We are writing SQL queries in the code.
Yeah, but you're not writing SQL queries.
Yeah.
Okay, cool. So, oh my god, where did my table go? Like, I don't know if this actually worked. So we can do this by trying .tables. This will show you all the tables that you have in your database. And this is user, which is amazing. So, note that, okay, let's say I want to create another table called fruit. And I'm just going to have an ID. I can type like 132 words per minute, so let me know if I'm typing too fast. Okay, and name. And let's say I want to have a boolean. So let's say like is healthy. Come on, like all fruit's healthy. It's kind of funny, but one interesting thing you should know about SQLite is that there's nothing that indicates a boolean. So you would just have to use an integer. So you would say, okay, 0 is false and 1 is true yourself. And no comma here. Great, now I have two tables, and it says fruit and user. Yeah.
What's the all cap descriptions? Are they syntactical?
Clearly didn't watch the video. No. Okay, so so the reason why I have all caps is to denote that these are SQL keywords. You can actually do lowercase. It's totally fine.
Oh, okay.
So I can do like a friend. Note this probably doesn't make sense.
They just stop there, yeah.
and that's totally fine. And I will have friend.
Yeah, for us, we use all caps just to make it helpful and clear that this is SQL
Yeah.
keywords versus things we're writing ourselves.
Yeah. So if you do write lowercase and you submit your homework with lowercase, we will tell you that is not good, because this is like how you should write SQL code. It's good coding standard. And also, as for like naming conventions, you should always have them all lowercase. So note that is healthy has an underscore. You wouldn't do like camel case or Pascal case. Cool? Okay. Is everyone on the same page up till now? Okay, cool. Now, I just made like a wacky friend and fruit table. Let's delete it. So let's just say drop table fruit. And then if I do dot tables, fruit's gone. Let's also delete friend. Dot tables, no more friend. Just user. Okay. Is everyone clear on creating tables and seeing how many tables you have in the database? Okay, cool. Now let's add some data. But before we add some data, I want to show you guys how we can even look into these tables. So if you remember from the video, we can select all of the items in the table with select star from and then the name of the table. So this is bad. I need to caps this. User. And you can see like literally nothing was returned. So now I'm going to show you how to add data, and then once we run this command, we'll see the data that's actually been added in. All right, so let's insert into user, and then recall how we had an ID, name, age, and email. I don't want to add into my ID because the database is just going to handle that by itself. So I'm going to add into these columns, name, age, and email. And note that you can just do enter in SQLite and it doesn't affect anything, it's just white space. In fact, it's probably readable for you to separate different clauses on each line. So now I'm going to insert with these values. So let's say my name, I'm 20, and my email is this. That's my actual email, but don't email me. Okay, so now we insert something into our database. Okay, so let's do that command we had earlier. Note that you can do the arrow in your command line, like the up arrow, up arrow, up arrow. So you can go to your last command and not type it again. And then, sorry, that was a fail. Okay, command D. Oh, SQLite. So let's see what happens when I just got out of SQLite. All my tables were gone. Don't worry, I can type really fast. Okay. Okay. Yep.
Yes. Did you have a semicolon at the end of your statement? Are you just hitting enter to...
Wait, go. You can go help her. Oh, really? Wait, don't worry about it.
But you're just hitting enter.
Yeah, just hitting enter.
Interesting. I'll come over.
Yeah, go over. All right, so won't make that mistake again. Okay, so we can do select all from user. Bam. As you can see that one there, that's the ID that the SQLite database starts at. It's not 0, it's 1, which is a little weird, but that's just how it goes. And then Elena was the name, 20 was the age, and that's the email. All right, so let's just add let's add Connor. Connor, are you 21?
No.
Wait, really? Okay, well that messes with my demo because I made other things based on the fact that you're 21. Okay. So then now we can do the up arrow thing and we can see. All right, ID 1 was me and ID 2 was Connor. Okay, so what happens if I try to add a piece of data and I don't specify the age? Remember over here, I said age is integer, not null. It means I have to specify age. But let's just see what happens. So if I say insert into username values Alicia, it gives me a not null constraint failed. And that makes sense, right? Cool. Okay, so what if I miss a column and I say insert into username age, and then for my values, I put age and I put the email. This is the error that you'll get. So knowing these errors is very helpful for when you're writing SQL code in your code. You'll understand what that means later when Connor does the demo. All right, so you guys so far know how to get all of the data from the table, and that's select star. Okay, but what if I only want certain columns? Well, I can actually specify that. So I can say select name and email from user. And if you recall over here, it gave me all the data, but over here, only the name and the email. And then, as you probably recall from the clicker question or polo question, you can do conditionals. So we can say select name, age, from user, where the age is greater than equal to 18. And of course, that's everyone in the database. But if I wanted to select everyone who is greater than 20, or age 20, I should expect Connor, right? So Connor's right there. Is everyone following up to now? Okay. Now, what if I want multiple conditionals? So in order to test that, let's add Alicia and make her age also 21. And then I can see that Alicia's been added. So Alicia's in my database, and note, I didn't have to add the email because earlier I didn't specify the not null constraint. So let's do our conditional again. And now I only get Connor and Alicia, but let's only get people whose name is Alicia and age 20. And the and is just the word and. So don't do like the ampersands or like the long L for or. And Connor has been not returned. Okay, now let's update data. So let's say I wasn't supposed to add my personal email and I have to add my Cornell email. So let's update my email. So do you guys remember what ID I had earlier for me? 1. Not 0, right? 1. Okay. This is also my actual net ID. Okay. Where ID equals 1. Oops, semicolon. Okay. Then if I look at everything in my database, or sorry, table, I should see my email has been updated. Okay. Now what if we're just salty that Connor and Alicia are 21? Let's delete them from our database. Okay. So I can do this with delete from user where the age is 21. And then I can look at my database again, and only I remain. Everyone cool up to now? Okay, awesome. So this was SQLite. The reason why it's so important that you know how to do this in terminal is because actually when you write SQL in your Python code, it will generate a .db file, which you can actually like do commands and interact with that file by running SQLite in the command line. So if you ever have like issues with your database, you can see what's actually being outputted by the code that you're writing to generate SQLite code. And it's probably really confusing right now, but you'll understand when Conra demos.
Okay, so now we just went over some SQL commands, and now you have this helpful tool to help you on the assignment and whenever you want to do SQL stuff. But now we're going to get into actually writing SQL within Python via the SQLite 3 package. So, oh, that's tiny. Wow. Well, that's 2. Alrighty, so you all should have received the demo code and downloaded off the course textbook. If you have not done that already, you should go to the demo for today's lecture and it will be noted at the top. But we have, ooh, small. Okay. Yeah, there you go. All right, cool. So let's kind of orient you all with the file. So first thing, these imports at the top. Import OS is just a pre-built Python package. You don't really need to worry about it for right now. But SQLite 3 is what we're importing for all the SQLite SQL stuff we're going to be using for today and for the next assignment as well. So just to orient you with that. And then, yeah, so this is going to be the package that allows us to write SQL queries within Python strings, which is super helpful to integrate with our application and all the stuff we do with returning responses and such. So this next part right here, you also don't really need to worry about, but just to go through singleton and like this get instance stuff, it's basically trying to ensure that when we create a class that will be interacting with our database driver, that we're only having one instance at any given time within our application. We're only going to call it once and instantiate it once, but we just want to make sure if we had, say, like multiple servers running this, or if we had multiple like threads on the same computer, just if we're doing special stuff to allow us to run this app.py in multiple ports, that we would still only have one database driver being able to manipulate it. And this is just making sure that we don't have issues where two entities are trying to edit the database at the same time and get clashing queries for something like that. So, but without that, the application would still work fine. But without further ado, we're going to go into the actual database driver class. So this is how we're going to manipulate our database and write our actual SQL queries. And we're using a class just to make it extra clean, and so we can define our like operator methods within here. So when we call it in app.py, everything is nice and abstracted, and we don't have to worry about it too much. But the first thing we need to do with any Python class is initialize it. So here we're going to start with creating what we call our connection. We abbreviate this to self.con. And this is what is going to allow us to actually like open up the file. So we're going to use SQLite.connect, and then we're going to connect to a file we named todo.db for our to-do app. Also note that whatever string you put in here, if this file actually doesn't exist, SQLite 3 will create one for you. So that's just like another handy tool. And then we're going to do this other special thing, check same thread. And we're going to set this to false. False. Yeah, you also really don't need to worry about that. It's another thing, kind of like with the singleton class, to make sure we're not trying to do the same things at the same time on accident. And then the next part, that's just initializing. So you can also think about like opening a connection, so to speak, is like you're opening like an Excel file. It's the like actually loading up on your computer. This is the data I want to work with, so connect to it. Yeah. So the next thing we're going to do is actually instantiate our first table. So we're going to make a new create task table method. Also, for those of you who are still getting new to Python, all methods defined within a class need to have the self argument as the first argument for the method, just like a little Python thing. Self is also analogous to like this if you know Java. But yeah, so now we make sure that we're defining our first and only table for the demo, and we're going to do like self.connection, so self.con, and then the first method, the main method we're going to be using for today is called execute. And execute, as it sounds like, it's just executing whatever SQL command we write next. So we're going to just use a string, but we can use Python's triple quotes to define multi-line strings just to make things more readable for us. But the first thing we want to do is we're going to create table, and we're going to name this table task. And then we're going to do what we were doing before. I'll make this lowercase, ID integer primary key, and we'll also auto increment. And then we'll make a description column. And then we want this to be enforced to be not null so that we don't have empty descriptions in our database. And then we'll have our done field like before. And we'll also do integer also not null. And then don't forget your semicolon at the end of the expression as well. So then one thing, we're going to do is wrap this within a try except. This is just kind of a little cheat code for us because SQLite 3 will throw an error if you already have this table in your database and you're trying to create it with the same name. And because we'll be like stopping our server and like rebooting things multiple times, we're just going to wrap this within a try except so that we don't have to stop our code from running. But this is just like a little hacky thing. We can do accept exception as E, and then we can print it just to show you what it'll say. But yeah, we're going to wrap it. And then after we have this method, we want to actually create this table on initialization of our database driver. So we can do self.create task table and then parentheses. Cool. Any questions so far? Good. All right, so actually, wait, let's see if we can run this up. Let's do Python 3. Right now, I'm just instantiating a database driver from the Python terminal. And then if we go back and look at our files, now we have a todo.db. You can see this guy right here. So it created the file for us, and if we go in, we should see a table called task with all these things. So let's go in and see what's up. And if we do .tables, like Lena showed, that's not good.
Oh, because you need to like import the file in SQLite.
Oh, whoopsies.
And I'm like, I forgot the commands. So.
Oh, it's right here. Oh, how convenient. Open file name.
There we
We
go.
love that. We love that.
We
Okay.
love, and you can.
There you go. Hey.
Cool. So this
Alright,
makes
cool.
sense now.
Yeah. All right.
Okay, pause for a sec. Does anyone need help? I can walk around.
Oh yeah,
We
Elena
did
is free to
follow.
walk around and help people as we encounter stuff.
Yes.
Yeah. All right, so now that we have our table set up, we're going to now see, we don't need this for our application, but just to show you, if we were to make a delete task table method, also self, we could also do self.con.execute, and then in here we can just type a string, drop table, if exists. So I don't believe Elena showed the if exists clause when she was going through SQLite, but this is also another useful thing so that you're not throwing an error on accident if the table you're trying to delete does not exist. And then we can say drop task. Don't forget your semicolon. All right, now getting into like a more useful method that we'll want is, say like we want to retrieve all the tasks in the database. So we can define get all tasks. So now we want to execute our first query. So I want to show you another way to access, run and execute. So when we do self.con.execute, this is actually returning us what's called a cursor object. You can think of a cursor as like analogous to when you drag your physical cursor on your laptop like over a spreadsheet, like you get, like it highlights all those boxes for you. That's kind of like the metaphor we'll be working with it to think about what a cursor is when it's like selecting data in a table. So here, what query do you guys think we should run if we're trying to select all of the columns from our data from our table task? Any volunteers? Can anyone give me the first word? Nice. All right, then. Nice work, teamwork. All right, cool. So now this cursor object, it's an object. It's actually not all, it stores all the data that we care about, but we can't like simply just like drop this and return this as part of our route. We actually need to parse it a little bit. So we're gonna make like a tasks array to start with, and then we'll run a loop, and then we'll parse all this data out of it. So for us, we're going to say for row in cursor. So like I said, with the cursor, you can imagine as we're dragging across our table, it's forming this basically like a 2D array. That's how we can think of it. So it's a list of lists where the first list is like a row, and then all of the items in the rows line up with all the columns defined in our table. So like if we have this row, it's a list object, so we can do tasks.append, and then let's actually construct our task object. So we'll say the ID is going to be the first column in this row. So we're going to index it with 0. And then description is the next column, and then done is the third. So we could do row 2. Oop. But now remember that when we defined our table up here, we had to say done is an integer, so it's going to be 0 or 1 to reflect true or false. So we want to actually cast this to a Boolean, which we can do with bool to turn this into a truth or false value. So just for Python, newbie Pythons, bool is like casting is basically turning like variables, like values of a specific type and turning it into a different type. So 0 or 1 casting it means it's just turning it from an integer to a Boolean. It also could go the other way. So if you did int on a Boolean, it would give you back 0 or 1. Oop, come back. All right, cool. So now that we have populated this tasks array with these custom objects, these dictionaries we've constructed from our data, now we can just return these tasks back. So also mind you, I want to completely populate the db.py file first and then move on to app.py to see how we actually use all these methods. So we're just going to keep going through these, and then we'll loop back at the end to show how we actually implement them for the routes. So next we're going to go through inserting into a task table. So like before, we're going to use our con.execute method, self, but we also are expecting to take into this method some data that we'll actually need to populate our rows with, namely a description and the done field. So for us, we can say like cursor equals self.con.cursor. So this is another way to instantiate a cursor object in SQLite 3. The first is either returned as self.con.execute, or you can also do self.con.cursor to directly instantiate one. But now this cursor that we've just defined has no data associated with it, we just have one. So now we can do cursor.execute, same method name, and then we can say insert into task, and then we'll want our description. All right, let's make this lowercase. Description, done, and then our values are going to be, now this is where some SQLite specific syntax comes up. We can't actually throw, well, as of Python 3, we could try to just like throw the strings directly in here, but it's better practice to use SQLite's provided question marks to indicate that this is a variable that will populate. And then now the cursor.execute method is expecting a second argument, being a tuple of these variables that will go into these question marks. For us, they'll be the description and done variables that we took in as arguments for our method.
And Connor made a mistake. Can you guys figure it out? Yes.
Nice, thank you. Yeah, semicolon, yeah. And so also mind you that the order that these question marks appear is the same order that they need to appear when you provide the values. If I wrote done description, it would put done in for the for what it's expecting to be a description column, and then that would throw some errors and not be happy. So make sure that your variable ordering is proper. So then after we execute this query, we need to actually save this in the database. So the cursor object has all this stored that it's going to run this query, but it actually doesn't do it in the case of inserting and updating and deleting until you actually commit it. So committing is just analogous to saving to our table. And then after the fact, we need to know that, so also know that we don't define an ID as a value because it auto increments for us. So SQLite knows that, hey, I need to do this for you when you're creating new things. But on the like application interface side, the API for returning a response, we want to provide the ID back to them. So to access that ID value, we can do cursor.lastRowID. So this cursor object keeps track of the last ID of the row that it just updated.
This is the same as like select from this table where ID is the last ID.
All right. Any questions on querying or inserting into the database right now? All right. All right. Following along with like our route patterns, we want to get a task by ID, a specific one. And then for this, we need to take in self as always, and then an ID argument. And so we're going to do a similar approach as the previous ones. We're going to instantiate a cursor, self.con.execute. And then who wants to take a jab at what query we need to write for this? So we know we want to select. We want to get everything. We know our table. What else do we need? Where ID, yeah. Equals. Yeah, question mark. Nice. Exactly. So we're going to use this again. So then here we want to provide ID. Also note that this second argument, it has to be a tuple. For new Python people, a tuple is like a list, but it has a fixed length, an immutable length. To define one element tuples, you need to have this comma right here. If we just did this, Python would automatically unwrap it and just say, oh, it's an ID field. I mean, it's an integer field. So we need the comma to say, oh, it's a tuple field, but it has one element being this ID that we have. And I always forget my semicolons. Thank you. Yeah. And then now for, just like before, we're going to loop through this cursor because it is still a 2D array, even though, well, it's not actually a 2D array, but we can loop through it as if it is. And we need to get back this actual task. So we have to go through it. And because we're only expecting one element, we can just kind of do some shady things and do like row 0, just like how we were doing before, and manually parse out our data. And then don't forget to cast your done field to Boolean. Question, yeah.
On the line where like you're setting cursor like up one, why didn't she make ID down? Like why didn't she make ID a tuple? And where you say selects from task where ID equals question mark.
All right, here.
Yeah.
Yeah, I guess the tuple part is just semantics with like how the execute method is made on like the actual Python code. The question marks are just like placeholders for variables, and then the tuple is where we provide all of those variables in the second argument. So like you don't need to wrap this in anything. Like it just infers it automatically for us. Like doing this would break the SQL syntax, I believe. Yeah, I guess does that answer your question?
Yeah.
All right, cool. All right, cool. So now that we have our row in the cursor, we returned once we looped through it, but say something went wrong, maybe we actually didn't add it properly or we didn't find it properly, then we want to return none. So just indicating, hey, like there's no task with this ID. Moving on, the next thing we want to do is update a task, also by a specific ID. Actually, I'm not going to do update task. We'll do app.py now, yeah.
Because you guys have the gist.
You guys have the gist, and you have the SQL
It's
syntax.
more important we go over the app.
Yeah. Okay.
We have like 9 minutes.
All right, now moving on to app.py. We have the same imports as before, instantiating a Flask app as usual. As you can see, I have all these placeholder routes, and I passed them. These are like the same ones from the previous demo, but I'm just going to go through and show how we use this new database that we've created. So the first thing we need to do is actually, at the top, import db. So we need to import this Python file we just created so that we have access to the class we just made. And then we can say like database equals db, which is the file name, and then .database driver, and instantiate it like that. So doing this, like as soon as we create this database variable, it'll call the init method in the class, which will then call the create task table for us to make sure everything's set up for us for this application. And then now, before we had like this tasks dictionary over here, this is gone now. We've replaced it completely, replaced it completely with this database object. The next thing we want to do is show you kind of how to also streamline how you're returning all of your responses, because we want to make sure that we're writing abstract code. So I want to actually make some, what I'm calling like a success response. I'm just going to take in some data and have like a default response code of 200 if I want to return a successful response. And this is where we can put like the json.dumps, success true, and then data is going to be our data, and then our code is going to be code. So I'm just writing this because we as you saw in the last demo in the assignment, write this line a lot, and we don't really need to, given that it's the same thing each time. All that changes is the data you're inputting in, and maybe once in a while the code, but for most cases we're going to use 200, and which is why I'm defaulting it right here so that I can omit it as an argument when calling it most of the time. And I'm going to do a similar thing for failed responses as well. So a failure response is going to take in a message. It's like, oh no, task not found, a string. And then its code is going to be 404 for us because that's also our most popular error code to return for our assignments.
For those of you who might not know Python that well, Connor is basically saying if I call success response with only one parameter, it gets automatically, the code gets filled in as 200. But if I do put 2 parameters, then whatever second parameter I put in, that actually is what code is.
Okay, so now because we've abstracted like this response format and then we have all these database methods we defined earlier in db.py, this route is as simple as just return a success response and then db.getAllTasks. A clean one-liner for this route. And as you'll see, a lot of the other routes we have are also much cleaner now. So when we call this, it's going to call the db.getAllTasks, which is then going to write the SQL query on our todo.db file, take that data, parse it with like looping through for row and cursor, and then throw that back as the data in the success response and return this JSON dumps package for the response. Just like walking through what's going on. Yeah. All right, now we're going to go through creating a task. So like before, we need to post the request's body. So we're going to do JSON.loads as before, and request data, and then we want to parse the description. So we'll say body description. Also, I want to show you a fancier syntax. Oh, come back here. A body is a dictionary when it comes through JSON.loads, and so you can access the dictionaries field with .get versus the bracket notation. And with doing this allows you to actually define like a default value. So for us, we may want to say like, oh, there's no description, but .get also is nice in that it defaults to none anyways, but we'll probably use default values later in the course. And then we want to go through task ID. Is going to be the database.insert task table, and we're going to provide this description value and default our done field to false. And then now, to make sure that we added this properly and nothing went wrong, we then want to query from our database this task by its ID to make sure that everything is going as according to plan. So now if we remember how we wrote the get task by ID, it's either going to return us a task object as a Python dictionary, or it's going to return us none if the task with this ID does not actually exist in our table. So if task is not none, we love Python English, then we can do return a success response, just providing our task as our data, and we're going to use code 201 to indicate a successful creation. Otherwise, we're going to return a failed response saying that something went wrong. Sad face.
You should make these descriptive.
Yeah.
So it helps you too. Do you want to first show this?
Yeah, let's show this actually. All right, so now I want to show this on Postman of actually sending these requests to make sure that everything is working properly. Sorry, we'll put the code back up in a second. Sorry about that. Okay, so now, all right, so a little Postman tutorial. This top bar is where you have all of your requests. So we're going to create a new one up here with the plus. Our URL, if you remember, is localhost and then port 5000, and we're going to do /tasks route. And then first I want to make sure that, where's my terminal? There you go. Okay, so we're going to do Python app.py. Task table already exists. So this is the exception we caught earlier because we already created a table, but we're trying to do it on every database initialization for our convenience, but everything's up and running. So now if we try to query, not that guy, all of our tasks, we should get success is true. There's no data because we haven't added anything, so let's make a new request to do that. So we'll copy this to a new request, change the method to post, go down to body, raw data of type JSON, and say description. That's not it. It's going to be hello, laundry. All right, and that's all we need to provide. Done field is defaulted within app.py. So let's see what happens now. Success is true. We have our data. SQLite starts incrementing data IDs at 1, not 0. And then we have laundry's laundry, and then done is false. And if we go back to query this, we should have it show up here too. So everything's working as intended so far.
And it should also show up if you do the .open, the file name of your database in SQLite, and you can see by querying your server, you were able to actually edit this database file. And Connor is showing that. Cool. Semicolon.
Every time. There we go.
See? And laundry's here. Isn't that really cool?
Yes, very cool. All right, cool. Next, we're going to get task. Also note that we're getting this task ID variable through the route up there, and then we're going to say task equals db dot get task by ID, throw in the ID, and then if task is not known, we'll just copy this, and then say task not found. And we don't need to put a code here. So as you can see, like this is dramatically simplifying the code that we're writing in app.py because we've abstracted these data operations into the db.py file. And then we didn't do update task or delete tasks, so we'll let you figure those out on your own or read the textbook, which also goes through these methods. But that's all that we have for today. Are there any last questions? Otherwise, you're free to go.